I'm going to do a bit of work on this old Heathkit IT-12 Signal Tracer. I've already got the thing apart because I've already started, and I'm just going to go through it and have a little bit of refurb on it and just tinker around, see if I can find any problems with it. I mean, I've had this thing for a long time, over a decade. I haven't used it in many years either. I thought I'd just put it apart and check it out and see if there's any problems which I don't know about, and just do a bit of maintenance on it really. The things are old. This is pretty old technology. I'm not sure what year this is. It might be 60s or 70s. I think it's probably 60s, I'm not sure. It might even be a date code in here somewhere. It's going to have old resistors and things like that, which you'll need checking out just to be sure they're okay. So I actually already started. I pulled the thing apart and sort of sat down and thought, actually, I think I'm going to start doing a video on this. So why not? So stick around. Don't forget to click like if you like these things. And subscribe if you're not already subscribed. So the first thing I'm going to do is start checking resistors out. Now I've already taken out this tube here, the eye tube, which is sitting over here on the desk. Just to protect it, I have one spare eye tube. So I've got some tubes which I purchased when I purchased this thing. So the tubes that are in this, I purchased spares of many years ago. I don't know if they're still any good. They're sitting in a drawer in a bag and stuff. So they may or may not be any good. I've got no idea. But I do have spares, but I don't want to go there. This is quite old wiring. It's hopefully not too brittle. The only thing I want to do is go around, check these resistors and make sure that they're okay, and try and decode the bands on these. So let's get closer, try and get so you can see everything I'm doing. Using my Fluke 177, which isn't because of the button. Those that follow the channel know what I mean. So you've got this resistor here. What's this one? That's also a cross capacitor, so it may or may not be a problem. 11.1K. We've got brown, black, orange, silver. So that's 1, 0, what's the orange? Orange is 3, 103, 10K. So it's 1K out. 10%, let's get out there. 10% is pretty significant. Okay. Let's probe on here. 76.6K. And this is, what colour is that? Is that green? I think that's green. Green, brown, orange. That's what it looks like. 5, 1 with 3 zeros. 51K. That's how I'm interpreting that. And we're getting 76. I may actually need to refer to the manual for this because it does have like an assembly manual. It tells you all the parts and where they go. So I may need to refer to that just to verify some of these parts are actually correct. So I'll probably do an overlay or something in the video to show what the value should actually be, in case I'm not reading the band correctly. I'm pretty sure it's green. I'm not sure. This one is orange, orange, yellow. We're getting 350K there. But orange is 3, so it should be 330K, is it? Yeah. So it's not that bad. That one's okay actually. So in here is yellow something, orange. 48. Is that violet? Could be violet. So that's 47K. We're getting 48, so that's looking okay. So this one here I'm suspicious of. Orange, orange, yellow. Get a good connection. That's supposed to be 330, so that's 370. That's out by 10%, so concerning. There's another one tucked just down here, trying to see where the end of the leads are. One there, and one here. 1K. And it is brown, black, red. That's 1K. That's actually alright. So there's another resistor here. .364 ohms, and that is orange, orange something. What's that? Brown. 360. So I think it's supposed to be 330 ohm. So it's out by 10% as well. Yes, it's almost like I should just go around and replace all of these, really. 10% out is getting a bit much. It's 5%, I'll be happy. If 10% is getting a bit excessive, I think. 3.5 meg. We've got yellow, yellow, brown, is that? Sorry, orange, orange, brown. Get it right. I think it was brown. That can't be right, surely. Maybe it's not brown. Can't quite tell. Maybe it's green. I think the green maybe is like a weak colour on these. Got 3 something. Orange, yellow. Yeah, okay. That's 10% out again. Or just under. That's not too bad. So there's actually not that many resistors in here to worry about. One more here which I've done. $77K. And we're getting, what colours are those? Don't know, something brown orange. Something 1. Is it 81 or 71 or I don't know, I can't see what that colour is there. Might be green again. 51. That would sound right, wouldn't it? 51, standard value. And obviously we've got electrolytics as well, right? So it's a big electrolytic cap in here which has got resistors across it, so I can't easily measure that because that will throw the values out. We've got 3 connections on this electrolytic capacitor here, and it says 50 millifarad, 50 millifarad, 20 millifarad. So 3 connections plus a case connection. So I'm guessing those are 3 individual capacitors based on the markings with a case connection. So I should be able to measure from the case to each one of those pins to find a capacitance value, but because there's parts attached to them, that will likely throw those measurements out. We can try though. So we've got the Peak Electronics ESR70 Gold out, which they sent me recently for review. And it's supposed to do in-circuit testing, so let's give us a go, see if we can ignore these resistors or not. .60 microfarad, 0.6 ohms. .60 microfarad, 1 ohm, that one's looking a bit worse. And in-circuit leaky. It could be because of the resistor across it. Try again. Yeah, 2.2 ohms. Yeah, there is a resistor going across to the grounding, so there's actually a resistor across it, so that could be causing measurement errors. So one cap definitely looks okay, the other two, don't know. You've got too much going on. The thing with doing stuff in circuit is you get all kinds of parallel reactances and stuff like that which mess things up. So I'm just going through and remeasuring these again to actually make a note of what they all are. And something occurred to me is that all these resistors have got a silver band on them. So what the silver band means 10% tolerance. Now I'm getting about 10% tolerance or less on most of these parts. So if they're designed with 10% tolerance on them, does that mean it actually matters? Well, probably not, because if they've got 10% tolerance on design, it's probably not that critical. So I might just go through and just check some of these, actually work out the actual percentages on them. And if they're in excess of 10%, then I will change them. Like the 10K up here, that's measuring 11.1. So that one is actually just over 10%. So that one I'll probably change. But I'll go through and work out the rest of these and see. We've got a 6.8 here, sorry, a 68K which is measuring 76. So 7K is like 75%. So I think this one here is changing. This one here needs changing. 330 ohm, 363. That's bang on 10%. Yeah, yeah. I might sit down and work out these and just see which ones actually really need to change. If it's within 10%, I think I'll leave it alone. Usually, to me, being more than 5% out would be bad, but the design with 10% parts, so it's probably not that critical after all. Maybe I'm just being too fussy because I've used to working on modern electronics where it's a bit more critical. So I think this actually brings us down to having 3 resistors to do, which are only just outside of 10%. So we've got a 10K, as I said before, we've got this 76.6, which should be a 68, and we've got this 374K, which should be 330. I think that's it. Not too bad at all, really. Right, so I've marked the resistors up. It's these 3 we need to replace. So what I'm going to do is going to cut those out, and then I'll try and solder in new ones, because these are wire wrapped, right? So they're actually wrapped through the holes, and then they're soldered, so it makes them a bit hard to get out sometimes. So these ways, just cut them out, and then when you get new ones, try and poke them through the holes in order to get that rigidity back in place again. So these are half-watt resistors. So I've got some half-watt resistors here. They're not exactly the same. These are carbon composite. I've got a metal film and a carbon film, so not exactly the same, but it'll have to do. And hopefully it doesn't cause a problem. So it might be a... Now I've got one end free, I might be able to feed this one out. Let's see if I can do that. I might have to take the tube out as well to stop it sucking heat away. We'll see how it goes. My irons are set a bit low, need more heat. So there is the end. There's the end there, which you can see was wrapped. Let's cut that off. Get the tweezers, they're not disappearing. There's one out. So that one there was a 330K. Which is this one here. I don't think I can get that through the hole. We'll see. See if I can do it. This is a rather heavy piece of metal just here, so it'll take a bit more to get done. Here's the hole, through the hole. That's a start. I think. No, I missed. It slipped off. That's a disaster. Actually, this one's just like a post. It's just like it's wrapped around. There's no hole to go through. That's probably why I can do it. So we'll actually just wrap it around and solder this one on in. Try and get a nice tight wrap on it. If I can. Then we'll solder that down like that. That should do it, the job. I'm going to use my other flux here, or my other solder, which has got more aggressive flux on it. Older gear, needs a bit more help with that. Yeah, that looks right. One resistor done. Try and see if I can get this resistor here to come free without cutting it. No, it's wrapped, so definitely not. That's well wrapped, that one. Let's just give us a snap. If I can. Where's the end? Is there somewhere? There it is. And this obviously sleeve because the distance has got to go. And I might put some heat shrink on the resistor I put on. It's quite a thick sleeve and I might just be able to reuse that actually. It seems okay, it's like it's in good condition. Thinking it might be going brittle, but it seems okay. Oh, look at that, came straight out, nice. So that one there is a 68K, which is this one. Now I'm doubting I put the right resistor in the right place. Check. Yeah, that's the 1K there. Got this resistor here to get out of that same position, so I might do that if I can. Might be able to lift that one out if I'm lucky. Now I'm doing this on here. This cap may need changing yet. And it's basically got tabs which look like they've been soldered onto the bottom of the capacitor. So this may need changing and redoing again yet. Maybe I won't commit too much to this. I won't wrap it, I'll just put it through and solder it in case I need to take them back off again. Let's just do it this way, I'm a bit lazy. lay it on top and solder it on. So I might have to change this cap anyway yet, which means I might have to undo all this work. Right, that's those done. Let's slide this back together and we'll pair it up and see if it goes bang or not. I have to reposition that resistor very slightly. So it's not touching against the back of this bracket. It's not much of a problem. Just like that. Okay. Problem is, once I've powered this up, it's going to have some decent voltage in there. There's no bleed resistors in there, I don't think. Noise is off. So we need to measure voltages. I'm not sure what a filament voltage actually is, actually. Let's see. Let's just tighten up this valve here first. This is, say, it's really loose. I just want to tighten these fingers up a little bit. Yeah, marginally better. Okay. Filament voltage, where the hell is that? Let's figure out where that is. So the I-tube's got a resistor on the back of it as well, just here, and it's supposed to be 1 meg, and I measured it as 1.18 meg, so that is 18% out that needs fixing. So I just realised there's a resistor on the back of here as well. This is a bad resistor, so I need to change that. Looks like it's not wire wrapped. I should just be able to desolder it and have it lifted out. Fingers crossed. So I've got a resistor here to put in, so we get on with that. Let's take this end off first because it's got the wire on it. I think what I might do actually is put some fresh solder in here first. Okay, spin it back around where it's supposed to go. I think we're just about ready, so I need to get set up to do the other valve voltage checking over here. Just there. I might do it that way around like that. Power is off. Levels turned down, everything's off. Meter on volts. There you are, now push the record. So I've just done a quick probing around, I'm just going to show you. This is at 210 volts input, and we're getting about the right voltages here. At 210. So they're about right there. But it's supposed to be 230 volts. If I did 230 volts, I'll put it up there again. So 230 volts is now 146 there, which is significantly higher. And this one's supposed to be 114, or saying it's 127. This is supposed to be 6, and you're getting 7.3. So it's overdriving things a little bit. Yeah, I don't know. It's a bit on the high side for my liking. So I've measured voltages on a capacitor here, and one of them was measuring 1.6 volt ripple, just this one here. So there's 3 capacitors in a single block, and they reference to this chassis, and the other 2 are doing like 10 millivolts. That's fine. This one here was doing 1.4 volts, so one of the caps aren't great. So I've turned the lights off so you can see the I-tube here. It's going to tap on that, and you can see it flicking. As I turn the gain up a bit, you'll see it closing up. If I turn on a speaker, you'll hear it. I'm inducing mains noise. Now, if this was set to noise, then this would be high voltage on the tip, and you shouldn't really touch that. So be careful about the switch if you own one of these things. So I thought I'd demonstrate this. I'm hooked up to the probe tip. I've got the noise output turned on. If I touch on the probe, 118 volts. This is why you don't want to be touching the probe tip when you've got the noise switch turned on. Even with the noise switch turned off, I've got a little bit of leakage there. I'm getting that 1.3 volts or so leakage, so there's something coming back through which maybe shouldn't be there. So there could be some leakage on something somewhere, but that's not really a big deal. One volt doesn't matter, does it, really? So I'm going to strap this capacitor across the original cap in here, and hopefully it will actually work and it won't be a total disaster. Biggest problem is a 150 volt cap. I've either got 100 volt caps or 400 volt. Obviously 100 volts isn't going to cut it because there's a 140 odd volt supply. So yeah, I need to do the 400 volt. I could potentially put two 100 volt caps in series. That's a workaround, but a little bit of a bodge. Sometimes you have to do that, but in this case I've got this one which I can probably shoehorn in here. It's barely going to fit. There's not much give in this, so I think I can get away with it. If I sleeve these wires here off the capacitor, I can probably manipulate it and get it to sit in there like that somehow, and maybe try and get it sitting nicer, but it's not really got a lot of room in here. I mean, I won't fit across the back there, can't fit it down here, don't need to buy the transformer anyway. Then we'll remeasure it, see if the voltage ripple looks any better. I expect it will. I hope it does. So I go there, this one I go to here. That can actually be shortened a little bit now. About there. Oh, too much. I shouldn't joke. After today's stream, the way things have been going on it, I shouldn't joke about things going wrong, should I? It's just like tempting fate, isn't it, really? Because you can almost guarantee that something will go wrong and I'll completely screw something else up anyway. And in the people which are watching the recorded video, which I'm currently recording, if you're wondering what I'm talking about, it's because I've been screwing up my live stream, or things have been going wrong with the live stream, which I'm currently recording whilst doing this, if I can get the sleeve to go on. Yes, I've had a few problems with the live stream today. Between me being an idiot not switching cameras over, and cameras freezing up and just not outputting the correct information. Well, not camera, it might have been the USB system locking up and ABS playing out. I think it's ABS mostly. It's been an interesting stream as far as problems, which I don't normally have. It's like I've been jinxed or something. It's all fun. It's the life of a YouTuber. So let's put some fresh solder on this one before I try and get the wire attached. A bit of a tight space to solder into, so I'll try not to solder everything else as well. Let's see if I can do this without my hands in the way, so the camera can see it. Because that's always quite nice to be actually having everyone see what I'm doing, which is what the point of the video is. Can I do this without blocking the camera? Maybe. Without burning wires? I don't know about that. Well, it's not falling off, so it must be attached. I'm actually able to tuck that in like that. It's just reaching. That's good. So let's try and get this through here. This one's going to be harder to record with me soldering at the same time. Let's try and do this. I'm trying not to block the camera at the same time, which makes this a little bit harder to do. Alright, that's on. I've got the polarity correct. That's always a bonus. We shall power this up and recheck it. Right, let's power this thing up and see what happens. Is this capacitor going to explode in my face? We don't know. Power is on there. Turn on the switch. Measure between here and here. There we go. Oh, ripple's going up. That's interesting. Maybe it's getting a back feed from that valve. Hasn't improved it much, has it? 1 volt, almost. You get 1.4 volts before. That's interesting. I was expecting better than that. has improved it, but not by as much as I thought it should. I mean, that's on the valve over here, right? Same place. It's the other connection. Where's your round place? Millivolts. That probably doesn't matter because there's no connection. 5.8 volts AC, which is one of the feeds for the filament. I think. I might have to check that actually. 6.2 volts AC. Alright. It's millivolts AC. Okay. So I wonder if it's like feeding through the valve a little bit or something. Because with that one and this one here, which are both in the order of 6 volts. Which pins are those, I wonder? So I've got the thermal camera out, so having a look around, see if I can see anything which looks like it's obviously bad, and everything seems okay, apart from the valves, which are obviously really hot. But this one's especially hot. I'm not sure if it's normal or not. I'm not really a valve expert, so I don't actually know. But this is measuring 153 centigrade right now. 157.8, this there. So, I don't know, this one valve seems to be extremely hot. I don't know. Interesting. Is it okay or not? You tell me. So I'll just recheck the voltages. It seems okay. Power is still on. Don't touch it. It will hurt. Let's turn the power off before I do something silly again. And zap myself or something. So I think it's okay. It's all working alright. Seems to be working alright. Oh, we haven't checked the hum. See if that's changed by changing that capacitor. You haven't checked for that yet. Let's make sure that's looking okay. Make sure the noise is turned off, otherwise I might zap myself with the probe. That wouldn't be fun. Okay. Yeah, it's actually better. So you've got the eye tube down here. I'm going to turn some lights off so you can see. Because it's not very bright. So you can see the green eye tube here now. And as I touch this, you'll see that closing. I demonstrated before. Yeah. Yeah, it is kind of closing. There you go. Yeah, so, but the actual hum whilst idle is definitely better. There's less hum while idle now, so that's an improvement. That's good. I'm happy with that. Yeah, that's good. So there we go. That's all working. The hum is better on the speaker. I'm happy about that. It's a nice little refurb done. I've been into this for ages. You know, I've had this thing for over a decade. I've been meaning to get around to it. It's just like, oh, okay. It seems okay now. So that's good. So don't forget to click like and subscribe if it's your first time here, especially. Oh, don't forget to check out the playlist over here. There's a playlist of things I'm fixing. There's a playlist over here for things YouTube thinks you should watch. There's a link here to subscribe if you haven't already done it. It's probably nagging you. And there's a link over here for Patreon if you want to help support the channel and donate so I can buy things like this, I suppose, or newer stuff than this, really. So yeah.